Geochemistry tells you so much about natural processes on the landscape, coastal processes, river processes, and in areas near human populations. There's another dimension to geochemistry, which is the contaminant story. Introduced concentrations of metals and other chemicals that are harmful to the environment and to ecosystems. So geochemistry tells you both about the environment and about man's activities and how that affects the environment. I'm Renee Takesue. I'm a research geochemist and I work at the Pacific Coastal and Marine Science Center of the USGS in Santa Cruz. We know a lot of the initial reasons why contaminant metals and other compounds might be enriched, but we don't know how they move through the environment. From watersheds where people live and work out through the rivers and into the coastal zone, and even into biota, especially contaminants that are associated with sediments, and many of those persistent ones are. When watersheds have specific types of sediment, those can be distinguished based on their geochemistry or their chemical composition once they reach the coastal zone. And how they move and where they end up with the contaminants associated with them is some of the things that my research is showing in Puget Sound. One of the recent studies we did looked at whether river plumes carrying sediment and contaminants were the primary mechanism of contaminants entering food webs, specifically filter feeders, so mussels, or whether it was pre-existing coastal sediment, which has a lot of legacy contamination from past industrial activities. And it was very exciting to see that there's a very distinct difference in chemistry between what the mussels were eating and the sediment in the bay. So yes, geochemistry is helping us to look at pathways of contaminant entry into food webs.